Scroll through any tech feed right now, and you will see demos of AI designed to build, think, and execute entirely on its own. But talk to the engineering teams actually maintaining enterprise software in 2025 and 2026, and the story changes. While 78% of organizations use structured machine learning operations, less than 5% have integrated true autonomous agents into production. Most current AI assistants are heavily guided tools, relying on a human to steer every move. The most critical choice your team makes today isn't which foundational model to use, but who holds the steering wheel during execution. Committing to an AI architecture is more than a software purchase. It is a high-stakes bet on how your company manages control, cost, and risk at scale. When you integrate AI into your product, you face a core dilemma. Do you construct a rigid pipeline, or do you deploy a dynamic agent? This is the structural divide. On the left, the workflow model, built on determinism. Data follows pre-programmed rules, hitting locked checkpoints. The path is identical every time. On the right, the agent. Given a goal, it iterates, self-corrects, and chooses its own path. Workflows optimize for predictability, which is why they are the standard for legacy integrations. Agents optimize for autonomy. They thrive in open-ended problem-solving, where the path isn't known up front. Once a system scales to handle thousands of users, these two architectures cannot easily be swapped. Choosing between pipelines and agents means trading immediate safety for long-term adaptability, a choice that dictates how your entire engineering team will operate. The workflow approach relies on rigid, step-by-step engineering. It treats the AI as a component in a larger machine. Retrieval Augmented Generation, or RAG, is the classic pipeline. The system strictly fetches external data before the AI is even allowed to generate a response. This matrix breaks down the costs. Workflows require a high upfront engineering to define exactly how data is retrieved and processed. In execution, like we see with a tool like Cursor, the human remains continuously in the loop, guiding the output and verifying code changes in real time. This allows for immediate failure discovery. If a step breaks, standard monitoring tools flag it before the task finishes. You gain auditable results, but the system becomes brittle. It cannot handle edge cases that weren't part of the original program. The agentic model shifts the responsibility. Instead of coding every step, you provide an open-ended goal and access to external APIs. The system operates on a reasoning loop. It autonomously writes a plan, executes it, evaluates the outcome, and self-corrects. Returning to our matrix, the setup phase for agents focuses on prompt engineering and goal definition rather than strict code paths. In execution, like with a tool like Devin, work is asynchronous. The developer assigns a task and steps away while the agent loops independently. This creates an observability hurdle. Execution becomes a black box, requiring specialized tracking tools to reconstruct the agent's logic. You unlock substantial human leverage and parallel scaling, but you sacrifice transparency. Critical errors might only be discovered at the very end of a long task. Beyond the engineering, we have to address the distinct, hidden financial costs of scaling these systems. Workflows scale efficiently. Running a fixed pipeline over a large dataset results in highly predictable compute costs. Contrast that with agents. Because every step in a reasoning loop generates new, unpredictable calls to the model, token costs can grow exponentially as the problem gets harder. There is also the cognitive load on your developers. If an autonomous agent fails after an hour of work, the developer suffers from context loss. They have to relearn the entire problem just to figure out why the agent stalled. Workflows avoid this, but they create constant fatigue. Staying in the flow state with a co-editing tool demands continuous attention. These two models discover failure at very different times. Agents require you to review the final outcome. Workflows allow you to review the process while it's happening. Workflows scale routine tasks with efficiency. Agents attempt to scale human cognition at a premium, variable price. To turn this into a decision, engineering leaders can apply a simple logic framework. This flowchart starts with a simple question. Is the task ambiguous and open-ended? If the answer is no, a workflow is your safest bet. If a task has strict inputs and outputs, adding agentic autonomy creates risk without providing any clear benefit. If the task is ambiguous, move to the second question. Is the cost of failure high? Regulated industries like healthcare mandate deterministic pipelines. You cannot have an agent making autonomous decisions on clinical data. Agents thrive where failure is cheap, and iteration leads to a better result. Matching your architecture to your specific tolerance for risk is the only way to avoid a deployment failure. For enterprise teams and regulated industries, the choice is clear. If you need millions of predictions per second with zero hallucinations, then you must default strictly to workflows. For startup founders and R&D labs, the math changes. If you are tackling research tasks and have the budget for high token usage, agents provide an output capability that fixed pipelines cannot match. Do not let viral marketing force your team into an unstable architecture. The most effective strategy for 2026 is building a bedrock of workflows for production while carefully sandboxing agents for innovation.